Welcome back all the fans and followers of space fiction. Launching from the surface of any planet is a big issue. To date, an enormous number of methods have been proposed to launch from Earth into space. Some of them are still unrealistic, dangerous, or simply difficult to implement. But let's forget about Earth for a while and move to the Moon. Many of the ideas that are a problem when launching from the Earth are not a problem when launching from the Moon. And so I thought about which system would be the best for launching from the Moon in terms of technical complexity and also efficiency. But let's talk about what we want to achieve first. If we want to get into the orbit of the planet, we must reach orbital speed at first. As soon as the body reaches orbital speed, it becomes a satellite of the planet, and the launch from the surface can be considered successful. The orbital speed, of course, varies depending on the size and mass of the planet and also our distance from its surface. The Moon is several times smaller than the Earth and also much lighter. As a result, it also has less gravity, which means that in order to launch from its surface into the Moon's orbit, we need to gain less speed than when launching into Earth's orbit. The orbital speed for the Earth's low orbit satellite is approximately 7.8 km per second. We must also take into account the Earth's atmosphere, so the minimum relatively stable orbit is 200 km above the surface. At the Moon, we don't have to take the atmosphere into account at all. However, in order not to accidentally hit one of the lunar craters, let's say we need to get into orbit at a height of 100 km above the surface of the Moon. The orbital speed at this distance from the Moon is approximately 1.6 km per second. As you can see, it is almost 5 times less than on Earth. In addition, the rocket does not have to overcome the resistance of the atmosphere, which will greatly simplify the whole launch. The Apollo spacecraft missions took off from the Moon's surface the old way. The spacecraft ignited the rocket engines that carried it into orbit. During this time, they consumed almost all the fuel they had on board. Elon Musk wants to repeat a similar scenario with Starship. But there is still quite a question whether Starship will be able to land at all. However, I have already addressed this issue in my previous video, to which you will find a link in the description below. Of course, my idea assumes that we will be already settled on the surface of the Moon for some time. So I'm not going to talk about pioneering missions here. So how can you simplify this ride into orbit so that the spacecraft doesn't have to spend tons of expensive fuel? Very simple. Using a roller coaster and magnets. Our goal is to use as many resources as possible, which do not have to be on board the spaceship. This roller coaster can be powered either by large solar panels or by a nuclear source in a power plant below the surface. The sun shines on the surface of the Moon non-stop for 2 whole weeks. However, for the next 2 weeks, the surface of the Moon is in the dark. At the same time, if the Maglev system is used, the total physical resistance would be almost zero. The spacecraft mission would then use its rocket to land on the surface of the Moon. Then it would move to the rails, and here, whether using its own chassis or using auxiliary chassis, it would be able to run at a sufficient speed to detach from the surface. If an auxiliary chassis would be used, this would of course need a wrench to brake and return to the start. In this way, the spacecraft could effortlessly gain much of the speed needed to reach orbit completely free of charge. Of course, after separating from the roller coaster, it would be necessary for it to start its engines and complete the ascent to orbit. And how much more efficient would this system be? It depends on what speed the magnetic rails could give the spacecraft. Today, high-speed magnetic railways on Earth can reach a speed of approximately 150 meters per second. In a lunar surface environment where there is no atmospheric resistance and where gravity is much lower, it would be easy to reach speeds of 500 or 1000 meters per second. And that's more than half the speed a spaceship has to reach when launching from the Moon. With an acceleration of 1g, we would reach a speed of 1000 meters per second on a track 51 kilometers long in less than 2 minutes. Importantly, however, the spacecraft would need less than half the original mass of fuel to reach orbit. And also, it could be lighter during the landing. However, if the spacecraft failed to start the engines after being separated from the rails, its impact on the surface would be inevitable. Therefore, as a safety precaution, it could start rocket engines while it is on the rails. In the event of an engine failure, it would not have to separate from the rails and could save the entire crew by emergency braking. As a result, it would also be a much safer launch than just by using rocket engines. I think that the magnetic railway has a much greater use on the surface of the Moon than on Earth. And not just because of lower gravity and the lack of an atmosphere. A huge amount of solar energy is available on the surface of the Moon during the Moon's day. In addition, moon dust causes abrasion on mechanical parts of any vehicle. The wheel chassis would need to be repaired frequently or completely replaced. The magnetic chassis does not have this problem. It works contactless, and even if some dust stuck to the magnets, it would simply fall off the chassis after stopping and turning off the magnets. And driving over the surface of the Moon would not swirl this dust at all, as the Moon does not have a dense atmosphere. So if we really want to settle on the Moon, we should count on the use of magnetic trains now. Thank you for watching, and the next time I fly by the Earth, I will send you another new video from the world of space fiction.